Hello, I'm Philip Murphy, the designer of Criterium Decision Plus, or CDP as we call it, at InfoHarvest Incorporated, based here in Seattle. In this presentation, I'm going to briefly introduce what's the point of CDP, what's the history of CDP, an incredibly brief introduction to multi-criteria decision analysis, and then a longer demo creating and running a decision model, and finally wrapping up with the next section of CDP, which is amazingly will happen in CDP 5. So the point of Criterium Decision Plus is that it fuses data and human values to recommend the best choices possible in the time available, and then communicates the decision reasoning behind those recommendations to a larger audience. And then as those actual decisions are implemented and their outcomes analyzed, we learn from the successes and failures as we push forward, hopefully building ever better models as we do the same type of decision over and over again into the future. The main takeaway from this slide is that the first version of CDP was the DOS version released way back in 1991, and the newest version, CDP4, has just been released and is primed for use in EMDS 7, which is just being released. So CDP is a tool to help people execute a multi-criterion decision analysis approach to decision making. It's easiest to explain what MCDA is by describing the basic workflow involved. Typically, step one is to explore and structure the decision, figure out exactly what the goal of the decision is, identify what objectives will let you know whether you're actually making progress towards that goal. Identify relevant criterion attributes which, if known about an alternative, gives you some insight as to how well that alternative supports those criteria. And then finally, identifying the relevant alternative themselves. What are options that we can actually choose from in this decision? Once you have done that, you go through a process of eliciting preferences so that you can determine weights for the criteria. You rate the alternatives against the criteria. With all that done, the CDP will then calculate the weighted sum for each alternative. You should then use the CDP analysis capabilities to validate those results. Results can come in two different types. You might have a winner-takes-all situation where the highest scoring alternative is the one that is recommended. Or, as Steve will show later, you may be in a situation where you're actually looking for a portfolio of alternatives delivering the most benefit for a given budget. The key to all of this is that multi-criteria decision analysis is essentially a synthesis approach. It brings together disparate information from across an organization. The more strategic the decision, the wider the types of information that will need to be used. Typically, most of the sources already exist within the organization, but some of these sources will be very credible, often the results of significant analysis or domain expertise within the organization. Other items may be entirely qualitative, i.e. strategic fit and legal jeopardy. But no matter the level of confidence you have in a factor, if that factor matters, it must be brought into the decision. Okay, now for the demo. Right, in this video, I'm going to show you key steps in using CDP to create and analyze a decision model. Suppose that we've been given the task of creating a recommendation as to which software project our team should focus on in 2019. We've been given a list of projects. We've been given some criteria already associated with these projects, some of which are quantitative, many of which are qualitative. The software projects themselves range from very simple consulting projects to creating a whole brand new, major new product. So let's start off. Let's copy this table of data that we've been given. Control C for copy. And let's go over to a Criterium Decision Plus CDP4 in this case, which has an empty brainstorm. If I go to the Edit and Paste Special menu, I can import this table, but I need to get it right. Are the alternatives columns? No, it's the criteria that are column headings, and the alternatives are row headings here. So if I pull that in, you can see I got it right, as in the alternatives appear in the alternative list over here, and the various criteria appear here. In the background, even though you don't see it, all of the original data that's in the table is also being kept in memory as we work here. So now I want to sort of design the my decision hierarchy. It's always very important to go down and clarify immediately what is the purpose of this decision, and it is to select a project, a single project here. So let's try and put some, organize this somewhat. Let's zip over here. If I look at revenue, development costs, and the possibility of follow-ons, these all come down to profitability. So I can group these by hitting Control G, and profitability. It's right there. And once I have that, these guys can be moved. I can drag them onto selected projects, saying these are definitely the key elements, key criteria I'll be bringing into the decision. Schedule and technical, these could be put together as feasibility. And then at the last moment, some of the upper management shows up to your team meeting, and they want to insist that we should think about whether or not the project aligns with strategic goals, because upper management always has strategic goals. And then at the same time, the the team raises their hand and says, listen, we care also that there's actually staff support for this, for whatever project we're looking at. So let's put these two under overall desirability. My spelling is terrible. There is a spell check, but I'm not going to use it because I need to get through this thing at speed. So again, drag that over. So now I have a decision hierarchy, or at least the guts thereof. So what I'm going to do is I'm going to turn this into a formal decision hierarchy. So I press a button up here. So as you can see, I now have what looks like a decision hierarchy. Let's have a quick look at, let's say, for instance, the question of technical risk. I see no challenge, tech quagmire. These are in fact exactly the ratings that we had in the original table, so I know my information was brought across correctly. But what CDP, of course, doesn't know is that from its perspective, when it imported these are just words. We need to make a natural scale out of this, that we can use for decision making. We have to make it an ordinal scale, and to do that, we have to make sure that we have these words organized in the correct thing. Being a quagmire is the highest level of technical risk here. Let's say straightforward. Put it there. Oops. Hit OK to that, say yes to this, and when I come back here, I now have a scale that goes from all the way from sleepwalk up to a known technical quagmire. Obviously, as you can see, I'm using a very non-formal scale, but it's a scale that means something to my crew. Now, one thing I want to emphasize about any type of ratings when you've got a qualitative scale, some of us, especially scientists, are inclined to be a bit wary of that, but you have complete control over exactly how the scale elements are going to be interpreted here. I can just do them linearly. It goes from basically, if it's a sleepwalk, then there's no difficulty at all under this. Now, one thing immediately I want to change this as negative, because I'm trying to actually figure out projects I want to do. On the whole, I like projects that are easy to do. Ones that are technical quagmires we should avoid. So I flipped the scale, and then if I wanted to, with these value functions, I could make it such that as long as it's any one of the first 3 or 4 scales is okay. It's only when I get close to the really dangerous stuff like known technical quagmire that I actually have a massive draft up here. So you have a lot of control inside CDP as to exactly how you want to interpret the qualitative criteria. I'm going to now jump a little bit. I don't have time to go through this stuff in detail, so I'm going to jump to a slightly more finished model, so I can then show you some of the analysis side. This version of the model is one in which I've cleaned up all the scales, given names to the levels, and rated the alternatives against all the criteria, and rated the importance of the criteria themselves. So at this point, if I go look at the overall decision scores, these overall scores are weighted sums of how all the alternatives rate against the criterion times the importance of that criterion. In the contributions analysis, you can see the weighted sums in action. It's pretty clear here that the major product gets most of its advantage from profitability. If we drill down to profitability, you can see that most of the major product's advantage in profitability comes from its revenue projections. Look at the sensitivity analysis. You can see that the weight in the model, of all the weights that are in this model, the one to which the outcome of the model, which currently says that major product is your best alternative, is most dependent on, is actually the weight of revenue under profitability. Were I to diminish the importance of that from critical to just important, you end up in a world in which the major product and the popular product are will have the same score. And if I continue to diminish the importance of revenue under profitability, you end up in a situation where the product 1 would actually be the best alternative. So clearly this is really very much dependent on exactly what's happening in terms of revenue estimates. And finally, in terms of analysis, let's quickly look at the trade-offs of lowest criteria. What you see here, for instance, if I trade everything off against revenue, you'll see that I'm trading $1 million revenue against $1 million in cost, given the scales I have and the weights that I've put into the model to date. If you had an actual accountant in the room, they would be a bit upset by this because they would probably point out that costs are immediate. We'll be spending them this year in 2019, whereas revenue are estimates for 2020, and so they should have been discounted. And so you should probably adjust the weight slightly to make revenue trade-off slightly less dollars per dollar than current costs. The more quantitative your model, the more quantitative scales you've got, the more that the trade-offs can give you ways of double-checking whether your weights make sense or not. Finally, you are likely interested in using CDP to prioritize features on a map in EMDS. Steve will show you how that works in action, but it's an important thing to know that in CDP4 you can use the export to EMDS command. So go to the model menu, go to interoperability, and choose export hierarchy to EMDS format. This command does two things. It first checks that the way you constructed your model, the length of names and the type of characters you have in the names are all compatible with EMDS. If you pass that check, it goes ahead and actually exports the entire decision model into a new file with an XML format that you can save and then use and load in EMDS when you go to run EMDS. That ends the demo. And finally, the next steps for CDP. In CDP5, we're hoping to introduce more sophisticated approaches to portfolio management, dynamic uncertainty assignment, sensitivity to ratings, not just weights, copy and pasting of submodels, and the importation of tables of data from, let's say, Excel to the hierarchy, and finally, something that will matter to the Forest Service a lot, the ability to install without requiring administration rights. Thank you.